Okay, we begin our recording. Chapter 1, exercise number 9. We just talked about the fact that positive is in whichever way you want. When we talk about position, we use the variable x or y or z. Often x for horizontal, y for vertical, but it doesn't matter. We talked about the fact that you can be on a sloped surface and positive could be up along the surface or positive could be down along the surface. And we talked about the fact that slowing down, decreasing your speed, is not necessarily negative acceleration, because negative depends on your choice of direction. And that is an important, it's a little thing. You can get all of this stuff. There's just a whole bunch of little things. And so let me show you this. I'm going to see if I can separate this. Different choices, same process. I'm going. When you move straight forward or backwards, or forward and backwards, we call that one-dimensional, along a line. And that could be this way too. And I know you know some of this, just to make sure that we get all these little pieces. That's the big thing. So I'm going to call in the something we're often familiar with, I'll call that the plus x direction here. But now down here, I'm going to call it the plus x direction to the left. And when you write this, because there's so many pieces to a physics puzzle, that it's not at all about just plugging. Anybody can plug numbers into an equation. But we're going to take it a little further and develop an intuition that is profound. Okay, I'll give you a situation. If an object is moving to the right, and I show the motion with an arrow and the letter V. And if it's going in the same direction, no turning and no change in speed, then I'd say V is a constant. Okay, and I want to do this, color code a little bit. I'll say V equals a constant. And that means, and trust me, people mess this up all the time. And it's like, oh, why am I not getting this? V is constant. In that case, I would say that V is a positive number here, positive, some positive value. But if I choose positive to the left, I would say V is a negative. Maybe you're going 60 miles an hour. Then it would be plus 60 miles an hour. Here, you'd still be doing the same thing, but it's minus 60 miles an hour. This is extremely powerful and useful and important. If it's constant, that is not changing in speed or direction, that's one-dimensional motion, then what I have is that the acceleration is 0. It doesn't matter how slow or how fast you're traveling, because acceleration is not speed. Acceleration is how gently, small acceleration, or abruptly, large acceleration, you change speed or direction, but we're going to leave that. So if you're just going along a line, how abruptly, large acceleration, or gently, small acceleration, you change. So often we'll have a high speed and a very gentle change that's safer. A low speed, you might have a larger, a more abrupt change. So you could have a small velocity and a large acceleration. Any questions about that example? Good so far? Let me know. Come on, jump in. Now check this out. Someone tell me. I'll do it in reverse order. I don't want to make you feel uncomfortable, but I do want to get you engaged. What if I change the direction? Oh, okay. Put it in reverse. V is this way. What changes? Eric, what changes? Yep. And what changes here? V is now what? Yep. So I did in here, because of this, then V would be negative. If the velocity is constant, what's A? If the velocity is constant, acceleration is still 0. Let me know, because we can pick this up or slow it down. But you guys have the gas pedal and the brake. But for the same motion, if I flip that, and for some reason I choose this to be positive, then V becomes positive. But if I'm not changing speed or direction, acceleration is 0. We call that a constant velocity, 0 acceleration. That's an important basic thing to build on. Now, let's go back to this situation. Let's make V to the right. And we're going to look at velocity and acceleration. Let's make V to the right. And let's say that you're increasing speed. Increasing speed. Can you guys read this okay? Irish says yes. Good, good, cool, great, great. Yeah. And the danger from a teaching, and you do it too when you teach, is that you have a few people saying something and you think, oh, everybody else understands it. And that's not always true. So you got to stop the professor and take it. Hey, Anna.
Hello.
How are you doing?
I'm good.
Good, good. We are going over, I'm recording this so that it can be available. We're going over exercise in chapter 1, number 9, and we're talking about acceleration.
Okay.
And then we're going to go to, what was it again? What was it? 14C.
All right.
So cool. I'm setting it up. I'm just laying this foundation. It generally confuses a lot of people. And if you think you're clear, just make sure. Okay. So we've got one situation. We've chosen coordinate right to be positive up here, and then someone else, maybe Max, chose left to be positive. And that's okay. It doesn't change what's going on. What it does change is the math and how you put it down, how you work it. So if you have now, we did a constant velocity. Now, if you have an increasing velocity, increasing speed, I should say, again, still one-dimensional because that's going to build up to other stuff. Then you can see that the velocity, I'll make it quick. Velocity, that arrow is in the same direction as that arrow. Velocity is positive. If it's increasing speed, now here's the key, guys, that just make sure you get this crystal clear. And if you can push yourself to get through chapter 8, which you won't do in this 6-week period, I don't think, but if you could work through and get whatever you can out of it and then go back through in your physics class. I'm pretty picky about this because when people, even textbooks and professors can say things that aren't exactly right. And it's confusing when you think about it and you go, that doesn't make sense. See, acceleration doesn't cause velocity to change. Don't worry about this too much. Acceleration just describes how the velocity is changing. What causes to make that, if it's a little toy car, how could you make that increase speed? If it's a toy car going across the floor, how would you make it increase speed? With your hand. What would you do? Anybody?
By pushing it with your hand.
Pushing it which way?
Well, in the diagram you drew to the right.
Exactly.
Yeah.
Or what's another way you could do it? You could push to the right, or you could pull it to the right, right? Maybe there was a string or something. But that's called a force, a push or a pull. That's what causes acceleration. If you have lots of pushes and pulls, you got to add them all up, and that's chapter 7 and 8. So that's what causes it to increase speed, some sort of push or some sort of pull or some combination. But the direction that you would push or pull is the direction of the acceleration. It's the direction that you either add or take away the speed. And so the acceleration, if it's increasing speed, that means that acceleration is that way. And for, I forget who I said here, for this case, acceleration would be positive or negative. Quick.
Positive.
Positive, because that is the same way as that. That's why you should draw that. Trust me, if you're really high level, you're going to draw stuff. But if I choose left to be positive, then acceleration is what?
Would it still be positive?
Not if I choose this.
Oh, negative, sorry.
Right? And that's why and so when you're doing physics, your eyes are kind of weird. In fact, physics folks tend to, when I got done with grad school, I had to train my eyes to go this way because I'm like going all over like that. And also V, both of these are in the direction here we called positive, but they're in the direction here we called negative. It doesn't change what's happening. It changes how we describe it. And that's critical because oftentimes, I don't know why, I keep getting the wrong answer because you probably got a plus minus error and it'll eat up your time, or you dropped a factor of 2, or your units aren't right. So there's a lot of little things, but if you get the more familiar with stuff, the faster you'll get at it. And you'll double check. So if you're building something, there's a saying, measure twice, cut once. For me, it's like measure 10 times and make sure I didn't space out. Well, if you're not a contractor and doing it all, even then. Okay, is that clear? V this way, increasing speed, A is this way. Why? Because that's kind of the direction you would push or pull to make it increase speed. Then that doesn't, forget about this. That's true. No plus and minus, no plus and minus. You only get plus and minus when you choose this plus, okay, plus, plus. Choose this plus, okay, minus, minus. Okay, now watch this. Flip it. This works for up and down, all kinds of stuff. This is a huge step. And again, the problem is that physics classes are going too fast. So now, I don't know, we're backing up, V. And we're increasing speed. Maybe not the best idea, but whatever. I could turn the car around too, it doesn't matter, whatever. Okay. Okay, in this case, V is what? Using this coordinate system. V is, yep, neg. I like that. See, abbreviation. That's why you start abbreviating stuff, like, then you just come up with one letter. And here, V is what? Someone else? I know you get this, but yeah, positive, right? It doesn't change what we're doing. We just flip the meaning of plus and minus. Now, what direction is acceleration on my picture here? Forget about plus and minus. What direction is acceleration, right or left? In this case.
Left.
Left, because you would push or pull it left to cause the acceleration. So you put it wherever, you can put it wherever, you can put it down here, A. It's not plus or minus until you choose this. And now acceleration is, for this coordinate system, positive or negative?
Negative.
And for this one?
Positive.
Boom, that easy. Once you get the hang of it. I mean, like, so many things are like that. But you got to go slow enough to get it, because your head, you know, just typically, we go, well, what do you mean you're increasing speed and your acceleration is negative? Yeah, that's just a direction. Notice if you increase speed, acceleration and velocity are always the same way. Why? Because you push it the direction it's moving or pull it the direction it's moving. That's how you're going to increase the speed. If that's negative, that's negative. That's plus, that's plus. That's always going to be true. Let's try. We only have 2 more cases. Then we can hit this example. All right, cool. Let's go back to traveling to the right. This avoids so much confusion. And then you start getting confused and you think, I can't do it, or, you know, it must be some other big problem, V. But now you're decreasing speed. Slowing down, but I don't like to say slow down or speed up, because you can have an object moving up and slowing down, moving down and speeding up. So the up and down, I had to train myself to just say decrease speed. Okay, let's go through this. Forget about plus and minus. What direction, left or right, is acceleration in that case? What direction would you push or pull it to make it decrease speed? Oh, Irish jumped out. Left. That's right. It doesn't matter where you put it. You can put it here, you got wherever. Just, I don't know. That's fine. Usually we put the V right on the thing, but A. That's true. Now, velocity is positive or negative using this coordinate system. Velocity is, you see it? Same direction, positive. Acceleration is negative. If, however, I flip my coordinate system, that is opposite that, which I have on my picture. So I can say, now I'm calling this negative, and the acceleration is the same, so it's positive. Whenever you decrease speed, these two are opposite. Why? Because to decrease speed, you push or pull opposite the way it's going. That causes the acceleration. Are we good with that? This is definitely worthy of getting absolutely, because it's going to save you, but And then I probably should let you guys flip it. I want to be efficient with the time here because we have a lot to talk about it. Otherwise, I would let you work together. In many ways, it seems slower, but you actually learn faster doing that. But if you're traveling to the left, but decreasing speed, what direction's acceleration? Traveling to the left, decreasing speed, what direction's acceleration? Right? Yeah. And then whether it's plus or minus depends on which of these you choose. That's just a reference. Coordinate systems are just a reference, right? You can cut up this board into a grid like this, rectangular grid. You can make right or left positive. You can make up or down positive. It's funny, people often teaching, they think they want to make it easier to always call up and right positive. You're taking away an important thing. You could also cut up this board this way. And that's particularly useful if you have a ramp, and you're going to see this in a physics class where you have something going up and down a ramp. You'll do that in the laboratory. So you can call whichever way, plus, minus. It's no biggie. Just getting the direction of acceleration is critical. So now we go into this. All right. A dog, Chuck the boxer, is running to the right. Is there, who asked? Well, let's do this real quickly. Let's see if we can maybe even say it. Chuck the boxer is running to the right. Say that's a boxer. He's increasing his speed. What direction is his acceleration? Don't give plus or minus because you don't have a coordinate system, right? If he's running to the right and is increasing speed, what direction is his acceleration? To the right. See? And then whether you choose that to be plus or minus is up to you. Okay, so then you go through in that. So is the increasing speed always a positive acceleration?
No.
No. Plus and minus is just your choice. That's, that's we've got that, even if we're not aware of it, it can be unconscious. And naturally, it doesn't mean people are dumb. It doesn't mean you're not capable. That's an important thing. So that's the A. B, another dog, Buddy, the husky. These were my dogs. Actually, both of them died last year. It's running to the left. Sorry, it's running to the left. And as he's running to the left, he's decreasing speed. So he's running to the left, decreasing speed. What direction is the acceleration? Don't give plus or minus. What direction is he running to the left, but decreasing speed? So acceleration is to the right. Opposite if you're decreasing speed. Is that plus or minus? I don't know, which depends on your choice. Is decreasing speed always a negative acceleration? Is decreasing speed always a negative acceleration? No. Okay, critical. Okay. All right, and then I think from that you can probably finish out that number 9. There are some solutions, not all. I probably could have put more in, but does that handle number 9? Is that, you feel good about the direction of acceleration? First the direction and then plus or minus based on your choice. Does anybody want me to say more about that before jumping into number 14C? Good. You might have got it, but now hopefully it's crystal clear, and hopefully, and then you really own it if you can teach it and share it. The other beauty of community college, I will say, is that we generally don't curve the class. Curving a class is sort of understandable at university. I was teaching at San Francisco State, and invariably there was a curve, and it was centered kind of around the 60s. So 60 to 80 was on an exam kind of a B, and 80 and above was kind of an A. And but when you have small classes, it's really, really unfair to curve it. In fact, I had an engineering class where the average was 90, and people that got 90 got a C on an exam. It was just a bad exam. So, you know, that's crazy. If a person made an algebra mistake, I didn't, and I got an A, and friend did and got a C. And the person knew just as much as me. So you get some of that weirdness. Curving also creates a competitive thing, and it does get competitive when you're going for a job and an interview and things like that. That's why you want to go as strong as you can, because it opens doors. But at a community college, generally you work together. And the more you can work together, and at 4-year 2, you have your little groups. So we don't generally curve things. So you work together and help others, and you will really get this in your class, and there will be plenty of people that need the help. All right, great. 2-dimensional sketches. This is a great segue for this. So, and if you have to leave, you can either just cut out, or make a note in chat, or just jump in. You're not interrupting me. We're doing this together. 14. I think Max, you wanted this one, right?
Yeah.
Are you still good with your time? Are you okay?
I'm good on time right now.
Okay, good. Okay, so 2 dimensions. The beauty is if you get 1 dimension strong, you can build 2, 3 dimensions, even more, not in space, but in other ways of thinking, Eric. And 2 dimensions, I already started to talk about a 2-dimensional grid, and we can have any sheet of paper. That's 2 dimensions. Anything along that surface is 2 dimensions, however you turn it. Vertical, horizontal, 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 north, east, south, and west, generally horizontal, even though you might have hills, and vertical. And super useful. But again, getting this foundation opens the doors. 2-dimensional sketches. So choose plus or minus. Visualize the process real quickly. You'll see here, you can make a list, get to know this. We are studying through chapter 5, time at an instant, and a change in time, or an interval of time, elapsed time also. Position, location, but where's the location? To give a number to it, you have to choose an origin and a plus minus. Displacement, you start here, you end up here. That's the displacement. Doesn't matter how you get there. Distance is how far it took to drive along the windy road. Speed, how fast. Velocity, how fast in what direction. Average speed, distance over time. Average velocity, displacement over time. Acceleration, and average acceleration. That's it. Master those. And people have a lot of trouble at the beginning. The first month of physics is often rough because of those things. When we do it in 2 dimensions, we simply imagine 1-dimensional motion here and 1 here, or 1 here and 1 here. So we got one direction we call X and the other direction we call Y, and we break it down. We visualize it, we sketch it. Let's see. Now, some of these take you pretty far. mean, this is no, this is not, some people teach a prep course and it's a baby course, and then you get to the real course and you go, well, that's not helping you. Not here. Projectile. Throw something in the air that is not affected by the air. You know, a ball, but not too fast and not spinning. A pen, and then we won't worry about rotation, but you can describe this on top of this and do all kinds of things. Here we go. Projectiles. We aren't going to deal with things that are affected much by air resistance. So toss a ball not too fast, or keys, a monkey, a banana, or your friend. We won't be able to deal with the rotation. Oh, I guess I said all that. I'm kind of a broken record. Object is tossed, projected. So you can imagine that you can, there's, just think of, this is what you describe in physics classes. Not because it's necessarily thrilling or anything you would do, but it builds the awareness and the skills. You can drop an object. You can throw an object down. While I'm pushing it, it's not a projectile. We call it free fall or free flight. Once I let go, though, during that period, just before it hits, it's free fall or free flight. I can throw it up, and once I release it, we call it free fall or free flight. I can throw it up and over. I can throw it horizontally over, or I can throw it down. And once I release it, we call it free fall. I call it free flight because it could be going up too. It's not even going up. It's called falling. Little terminology. Okay. So it's tossed up in the air. The states we will be interested are just after it's projected up. Oh, okay. I was going to go on this. All right. So let me just start. Doesn't matter which way you go, left or right. Just after it is projected up. So let me make my object black. All right, going up at some angle. In physics classes, you worry about the angle, the speed, how much in each direction. I'll just go up this way. Don't do 45 degrees unless you mean 45. The states will be just after it's projected at some angle from the horizontal at the highest. Oh, projected some angle from the horizontal. Oh, horizontal. What's that? Oh, okay. Cool. Let me do horizontal. So whatever you call it, you can say that this is horizontal and that's vertical. And of course, this is down and up. You're going to decide on plus and minus, but that doesn't change this. Okay. At the highest point, when it gets back to the same height it was released, and then just before it hits the ground. So you're throwing it, and that kind of makes sense that the ground might be down here. It's going to go up, and if you know how things go, something like that. This really trains your intuition, which is critical. Engineers without intuition get laughed at behind their backs. Well, sometimes to their face. Released, highest point, when it's back to the same level it was released, and just before hitting, because once it hits, it's different physics. Now you know that my method, which is designed to train all the subtlety and correct, we'll say, I'm going to call this 1, state 2, state 3, and state 4. You can start out 0, that's fine, but I like to count the moments in time that I am interested in. Sub-problems, it's only 1 and 2. When you get into physics class, you get more going on. This is going to make it easier, much easier. Question so far? We good? Reading and taking the words and drawing a picture is tricky in a lot of ways. You can ask someone to describe a picture in words, and then everybody else draw it, and people draw different things. So it's a challenge, and you'll get lots of practice with it. Just after release, at the top, at the same height it was released, and just before hitting the ground. Now, show the positions and position variables for each of those states. Show the numbers you use for each state, as always. So 1, 2, 3, 4. Now, it's 2 dimensions. So I'm going to say, I'm going to use blue and green. And I'll call green. So this has a position x1 and a position y1 because it's 2 dimensions, x and y. You don't have to use this coordinate system, but why wouldn't you? So I'm going to go over here and I'm going to show my coordinate system. And I'm going to call this plus x. Usually I'll put the units I use. And I'm going to call up because it goes up. If it doesn't go up, I call down positive. I'm going to call this plus y. That way I can always look at it and not slip up. So that's got some x1 and y1. I could choose y to be 0 here or 0 here. I could choose x to be 0 wherever I want. It doesn't change what's happening. Over here, I've got x2, y2, x3, y3. You get the hang of it, and it gets easy. x4, y4. That's what goes into your algebra and equations. But we need to keep track of what it means, or else we'll be lost in the problem. Stop me if you've got any question. As always, part B, as always, show your chosen plus directions. So I do it naturally before I even asked. I'm always going to do that. It's true, I could do the stuff almost in my head. Why? Because I've done it a lot. But might I make a mistake? Yeah, if I do it in my head, if I really care about it, I'm not going to do it in my head. C, show the velocity vectors. Here we go. I showed that one. So I'm going to call that V1, going that way. But it does not. This is the angle of projection. But of course, the ball or whatever doesn't go that way. It curves. Why does it curve? Why doesn't it go that way? Why does it curve? One word. Gravity. Yeah. And then that, like, what is gravity? And that's a very deep question. And we won't go there. But we got the sense that things are pulled down in a sense. How does that happen? Well, Newton didn't even know, but he knew equations and stuff. So, all right, cool. So at that moment, has it stopped at the top? What would happen if the ball went here and then it wasn't moving at all? What would happen? What would happen if you threw it and then at the top it stopped moving? Boop. Fall, right? So it's still moving. It's just not moving up anymore. It starts moving down. It was moving up, 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 down, down, down. So at that point, it's neither moving up or down. So it's moving horizontally. I won't do too much information. You'll get this a little later. And now it's still moving horizontally. but down. And so I'm going to go like this, tangent to the path if you want. There's some subtlety in here that's probably too much right now. And then it curves downward, so it's heading even down here, V4. And each velocity has an X part and a Y part. And that's how you do these problems. You divide and conquer, and that's built up in chapter 5. And when you can do that, you're golden. You're over a big hump. Any questions? Positions, those are the variables. Velocity, I show the arrow and I label them, V1, V2, V3, V4. Give me some response. Any questions or? Come on. In class, I can see your faces at least. See if you're squirming. So far, no questions. Good. Hannah, how are you? Is this okay?
Oh, yeah, I'm following along good.
Good. Cool. All right. So, because see, describing motion, again, this is the brilliance of Galileo. And Galileo, among some other things, but this is one big part of it. And it opened up to Newton. And then with Newton, you have the scientific revolution. I mean, game on. The people started learning stuff at a crazy rapid pace, much faster than they ever had before. And so breaking things down into minute detail that can be related, and again, related through algebra. So you're going to have basic ideas, but you're going to take those and make them fit different situations. So you take a basic relationships, make them fit maybe 1 to 2 or 1 to 3 or 2 to 3 or 1 to 4 or 3 to 4 or whatever. And then you just do the plug numbers in or algebra or whatever. Okay, so this is rather profound. And so we go like that. And D, show the acceleration vectors as an arrow and a labeled variable for each of those states. Now, I probably had a little bit of discussion about that in here. If there's no air or not enough air to affect it, you know, like a little steel ball or something. A ping pong ball gets affected by the air too much, but a golf ball, but they got the little bumps in it because of the air factors. So the real deal, but that's very complicated. So we go to the basics. Air isn't affecting it. Is there anything pushing or pulling it while it's in the air to the side, horizontally? Anything pushing or pulling, anything pulling it this way or pushing it sideways? You always get pushes and pulls from things touching it or from some mysterious forces. There's 5 of them, but generally gravity, electric, and magnetic, and then 2 nuclear forces. And so it may not be obvious, but during this whole time, the acceleration horizontally, and I can put it up here, and I do in chapter 7 and 8. I show you ways that will help you train and learn so much faster. I can write it here, AX equals 0. I don't really show you that, it's a little bit advanced. So I could say A1 in the X direction is 0. A2 in the X direction is 0, but it's always 0 because it's neither going to speed up nor slow down horizontally. The reality is it will, because of air resistance, it's going to make it slow down horizontally. So this is a model a 3x equals 0, a 4x equals 0, or just ax is 0 all the time. And then vertically, now, this we built on this. So this is beautiful. We're coming to a conclusion and bringing this all back. As it's moving upward and to the right. But let's look at its vertical motion. As it's moving upward, let me show you this, chapter 5 in Drive. It is moving partly up. We call that V1x. It's a lot of, right? It's like a 1,000-piece puzzle. How can I do this? You can't do it, not in your head. You do it on your paper. And you get the answer. You go, how did I do that? You just took one step at a time and repetition. And V1y. That's never going to slow. It's going to keep going. V3y, V4y. Oh, sorry. See what happens. Anybody catch my mistake? See, that's a problem with doing straight lectures. It's hard for people to follow. This is that's x. That's y. And eventually I would catch it because I've written it that way. I'd like to say sometimes I make a mistake on purpose, but that time I was just talking and writing. But here, V2y is 0. So from here to here, I'm decreasing speed. So someone, you got to get this. From here to here, what direction is the acceleration vertically? I'm going up and decreasing speed. What direction is the acceleration if you're going up but decreasing speed? Just like the car example. Object is moving up, whether it's just straight up or up and over. When it's moving up, it's going to decrease speed unless it's got wings or a rocket. As it's moving up and decreasing speed, what direction is the acceleration in the vertical? Is it up or is it down? Right? It's opposite the velocity if you're decreasing speed. Whether you call that plus or minus depends on this. But we could have different coordinate systems, but we would all agree if it's moving this way but decreasing speed, acceleration is opposite. Everybody cool with that? That's why doing the basics was so important. On the way down, what's going to happen to its speed? Stay the same, increase, or decrease? The vertical speed will increase. The horizontal will stay the same. It'll be constant. Acceleration is 0 on the horizontal. But, okay, so it's going down and increasing speed. What direction is the acceleration? Not plus or minus, what direction? It's going down and increasing speed. What direction is the acceleration? For 500 points. Keys to a new car. Down. Going up and decreasing speed, acceleration is opposite. Going down and increasing speed with the motion. And even here, there is acceleration. Why? Because it doesn't stay this way. It's changing. Decrease, 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 increase, increase, increase the entire time. I could say A1y is down, A2y is down, A3y is down. Just write notes. A4y is down. If I call it positive, then it's negative, 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 negative. And we have a name for that, which is a little bit misleading. We call it, first I'm just going to call this down. We call it the lowercase letter g. It is not gravity. It is because of gravity, but even that's an interesting question. If I choose up positive, then that is negative for up positive plus y. If I choose down positive y, then that's a positive. And that's a certain number that you'll come to know. A lot of details. I mean, look at that mess. It's funny, I'll do a class and then I'll Zoom with a meeting of faculty and managers and whatever. And I'll have this on the board and people go, ah, oh my God, that's so, it freaks me out. Yeah. My students can do it. But just like any great task, you do it little by little. I've got my neighbor and my friend who's also a contractor working on a garage deck thing that they're finishing up. And I just, you know, we joke a bit, but, you know, like I said this morning, it's, you know, it's not one person. Everybody does their role and you break it down. You break it down. This is why you get paid. You know, whether it's evolutionary biology, forensics, whatever it is, because it's how you do it. And that, again, often isn't trained. But by doing this crazy system here, the training is profound. And once you have that, you've got huge skill. That goes through D. Any questions? This is going to be a perfect timing. I should go get my plug. Are we okay? Give me a thumbs up or an okay in the chat, or an okay verbally if you would, so I know. Okay, we got Anna's okay. And we got Irish is okay. And Max, you okay so far? And New, how are you doing? You okay so far? New? Good. Great. Okay. And Anna, is it Anna or Anna?
It's Anna.
All right. I'm going to get a plug because if my power dies on my laptop, which I usually have it there, then we're in trouble. So if something funny happens, that's what happened, but I think we'll be okay. Okay, so the next question is, think about this. Part E, we're almost there. I want you to show delta X from 1 to 2 and delta Y from 1 to 2, then do it from 1 to 3, then from 1 to 4, 2 to 3, 2. You will be, this is so advanced. It's so cool. So you can do it. My puppies got into my room and then they got locked in for a while. before I knew it, and they created a disaster. Hey, Luigi. Luigi. Come here. Oh, Stella. Okay. She's 6 months old now. She was a tiny baby, but Estella, she's getting big. This is just comic relief here. Oh, everything. Okay, you're there. Luigi, come here. Oh, he's a big guy. They're brother and sister. And here's Luigi. Okay, so now you've met Stella and Luigi. Okay, guys, out you go, little monsters. Okay, now we need kind of a break. That's the other problem with physics classes, is that there's so much to process. So we more and more do something called flipping courses, because that's the most powerful way. That requires you to be unusually organized and determined and disciplined to prepare before class and to stay on schedule. But the learning is much accelerated. Okay. Horizontal displacement, delta x. So my horizontal displacement, let's get rid of, well, kind of a mess. So let me just get rid of a few things so that doesn't overwhelm too. I'll keep my x's and y's. Okay. And so, you know, keeping it clear is critical. And again, people that get paid for it do that. It also saves you time. So horizontally from 1 to 2, the object goes from there to there. So I would call that delta x 1 to 2. 1 to 2. This is a unique notation that I hope people will, I'm writing an article, I hope people will start to adopt, because it's so much easier to catch on. Vertically, you go from here to here. So that would be delta y 1 to 2. And in our equations and our problems, we're often asked to solve for these things. But because so much is going on, and there often is not a nice systematic way of labeling this, students naturally get confused. Delta y 1 to 2. Now I can also go 1 to 3. So delta x 1 to 3 would be here. What is delta y from 1 to 3? Luigi, here you go. Come on. Out you go. Go on. What is delta y 1 to 3? No. Delta y 1 to 3. Anybody?
Is that the distance or the displacement?
Displacement. Yeah. And how much is it? Give me a number. Bye, New, if you haven't left. Oh, she left. Okay. You'll get it. It's just right now you're not seeing it, but you'll see it. The vertical displacement from 1 to 3, 1 to 3. The vertical displacement 1 to 2 is here up to here. 1 to 4 is here down to here. So that would be delta y 1 to 4. Delta y 1 to 2. What's delta y 1 to 3? What if you you start somewhere, you travel around and you end up in the same place? What's your displacement? What's your change in position? You watch this. This is good. We'll get this. You'll get it. It's once you get it, it's not bad. This distance, if I go 1, if I travel along here, say a circle, the distance I travel, 2 pi r, the circumference or whatever, and I end up at the same place 2, my distance I ran around the circumference 2 pi r, but my displacement, I ended up at the same place. My change in position ultimately is 0. So distance and displacement are critically different terms. And while your field may or may not ever have you deal with that, it teaches a way of thinking and it opens up some other physics. So my distance would be here, my displacement would be 0. In this case, the distance vertically, you go up and then you come back down. But at 3, you're at the same level. So delta y, 1 to 3, is 0. Delta x, 1 to 3, is here to here. And now we're seeing physics before jumping into equations. The huge problem with our physics teaching. Delta y, 1 to 4. Delta y, 2 to 4 is from here down to the level of 4. Delta x from 2 to 4 is here over to where 4 is, or 2 to 3, or 3 to 4, horizontal, vertical. And that's what you're asked to solve. And frankly, it doesn't get much harder than that. So push a little bit to see that. Yeah, then you do the algebra. But then if you write the algebra with this notation, you will remember what it means. And the problem, when you know something really well, it can be hard to teach it. And so a lot of your physics professors know things really well. Particularly university, they don't teach very much, frankly. They just present some things. The TAs, or also called graduate instructors, or graduate student instructors, do a lot of the interacting and tutors, but they don't really teach that much. And so they forget, or sometimes very often don't realize why students are confused. And then they say, oh, some people can't do it. It's like, no, that's wrong. They write things in terrible notation. This is a common way of writing an equation. And students get totally confused, but I'll teach you in this book how to write it. It's the same thing, but it's clearer and it connects with your picture and it builds intuition and it shows you can learn physics. Anyway, let me see. I'll hold off on that. So Max, does that handle? That's C was a, you know, this often happens. You guys are great. Doing number 9 and then doing 14C was just a wonderful set. And also I'll share this link. You could look at it again if you needed to, but once you get it, you just keep doing these exercises. And again, you can check with each other by just popping in to use this Zoom room. And you can hold up your work or draw on the wall or whatever you got. Does that help? Was that helpful? Cool, Max. Any other questions? Now, if, sometimes I'll explain something, you still might not get it because I had that experience as a student myself. It's like, negative energy, I don't get it. And I had a preconception. That's my favorite one. I remember fighting that and then like, oh, but it's an important little point there. It's, in a way, it's not a big deal, but okay, cool. Max got to go. You guys, Irish, Hannah, any other questions?
None about the actual problems. I had a question about, I think you said you wanted us to turn in flashcards. What would be like the essential way you would
Oh,
want
no,
us to?
no. I do that in my astronomy class, but for you guys,
Okay.
just use it if you want. It can be good because it just refreshes, like distance versus displacement. I mean, once you get it, it's, distance is how far it traveled along the path. Displacement is just where you started and where you ended up. I don't care how you got there.
All right. All right. Thank you.
Yeah, good. Yeah, and those are, because there's so much. I mean, we've only gone a little over a week, so great. Anything else?
No, that's it. Thank you for today, though, Professor.
Did it help?
Yeah, it did actually. I was actually stuck on 14 as well, so that was really helpful.
I mean, and that's a high level. So you're ready to move on. And then you're going to see, we're going to build back. We're going to still take this and build up some amounts and some units and some building an intuition and then the algebra.
Yeah.
And you will be rocking.
Yeah. All right. Thank you.
Okay. Thank you. Thanks for coming. Irish, anything? You're good? Okay.